For a problem like this, you can apply the same concept, right, that we applied previously. Here, it's about identifying the inner function. So here, the inner function is actually this part, 1 minus exponential ax. So that's the inner function. Therefore, we can use that part as our substitution. But to do that, the derivative should be inside the integral. Right? So what's the derivative of 1 minus exponential ax? That is minus a exponential ax. I just applied chain. So here we have exponential ax. So, but we need that minus a term. We can easily create that by multiplying and dividing this integral by minus a. Minus a over minus a, that's just 1. So that's the idea. Then we can take this minus a out as a common, as a factor, right? Like this. Then basically 1 minus times minus a exponential ax dx. So this is the substitution u. This is the derivative. Basically, if you observe carefully, you can understand this part is basically du, right? Minus 1 over a u to the power of n du, right? Once again, here we can write that form, the form that I mentioned previously. We can use that form. We can express this using that form like this, times the derivative of the inner function, then dx. So that form is quite important, right? So basically, this is the inner function. So you can apply this idea. So if I express this using a composite function like this, f of x times the derivative of, not f of x, we need a composite function. Let's say f of g of x times the derivative of g of x. If you want to integrate such a function, answer is very simple. That's the answer. So because the derivative is here. So in such cases, we use u equals g of x substitution. In everything reduced to this form, f of u du. Because du over dx equals to d over dx gx. If I differentiate that. Then basically, in other words, du equals to d over dx g of x times dx. So basically this part, that's du. And this is u. So f of u du, then we can integrate. So the real key here is identifying the inner function. So therefore, don't need to worry about n or about the square root. Yeah, for square root, don't need to worry about that. Focus on the inner function. Choose substitution accordingly. Thank you very much.